Snow is heavy, unpredictable, and persistent. If your structural design doesn't account for it, your system could sag, shift, or fail. Snow looks beautiful from a distance until it's sitting on top of your solar array, adding thousands of pounds of unaccounted weight and putting your project and your schedule at risk. When it comes to solar design, winter is more than a season. It's a structural challenge. And if you're building in the Northeast, the Midwest, or higher elevations, you already know snow, ice, and freeze-thaw cycles can do serious damage to systems that aren't built or designed to handle them. At Pure Power Engineering, we help developers and EPCs stay ahead of the winter curve with structural designs that are built to take the load. Let's walk through what you're really up against and how smart engineering makes the difference. First up, ground snow load. Every site has a unique snow load requirement based on elevation, local maps, and regional code adoption. Some states follow ASCE 7. Others have stricter local standards. If you use generic values, you could get rejected by the AHJ, or worse, build something that's structurally under-designed. Then there's drift and sliding. Snow rarely sits evenly on a solar array. It drifts, piles up on canopy edges, and slides from upper rows to lower rows, especially on tilted or multi-tier systems. That creates asymmetrical loading, which can twist and stress the structure in many ways that engineers overlook. Now let's talk about structure types. Each mounting strategy has its own winter challenges. On rooftops, you need to verify the building can handle both solar, dead load, and snow accumulation. Sometimes that means reinforcement. On ground mounts, you need enough clearance to prevent snow burial and foundations deep enough to resist frost heave. On carports, you need to maintain vehicle clearance and resist drift loads, wind uplift, and sliding snow. It's not just about holding snow, it's about holding it safely in motion. Freeze-thaw cycles add even more stress. Snow melts during the day, refreezes at night, and expands inside joints, conduits, and enclosures. This can lead to cracking in structural members, ice damming at the gutters, water intrusion into electrical components, and falling ice hazards for vehicles and pedestrians below. So how do we solve it? At Pure Power, we engineer systems with accurate snow and wind load analysis, optimized racking and foundation design, carport structures designed for snow clearance and drift resistance, full structural calcs and stamp drawings for AHJ approval, and lastly, close coordination with racking manufacturers to verify cold climate compatibility. The bottom line, snow is heavy, unpredictable, and persistent. If your structural design doesn't account for it, your system could sag, shift, or fail. At Pure Power Engineering, we design solar structures to stand strong in July and even in January. Planning a project in a snow zone? Let's talk about how we can help engineer a system that stays safe, passes code, and performs in every season.